Hello and welcome back to the Code Athlete. This evening I will attempt problem C from the Kickstart Round A 2022. It's called Palindrome Free Strings. I hope the audio will be okay. It's raining outside and on the windows, so I hope the sound quality won't be in any way bad. Yeah, let's dive right into the problem. So, we are given a string S consisting of characters 0, 1 and question mark. You can replace each question mark with either a 1 or a 0. Your task is to find if it is possible to assign each question mark to either a 0 or 1 such that the resulting string has no substrings that are palindromes of length 5 or more. No substrings are palindromes of length 5 or more, okay? I'm already wondering about the number 5, if that's in some way special. So is it maybe that as soon as you take the length 4 palindromes that there will always be a palindrome? I guess you could have the string 1 0 1 0 1 0 1 0 if you take 4 consecutive, but then if you take 5 consecutive, okay, we'll do this in another. Let's just read on. So in each test case we have 2 lines. N is the length of the string S, and the next line contains the string S itself. And then we have to output Y is possible, if there is a possible resulting string, and impossible otherwise. So only these two we need to answer, okay? Sure, how long can S be? Up to the power of 10 to the power of 5. And here it is possible. It says here by the sample output. How would we go about this? If you can't have 5 character palindromes, then this can't be 0, 1. And if this, okay, and this can also not be a palindrome, so these two characters cannot be 0, 0 and not 0, 1. So in either case, this can't be a 0, it has to be a 1. And 6 numbered palindromes. So this can't be a 6 number palindrome, but we have a 1 here. Maybe I will already write down all the possibilities for this. 3 question marks. So we have 0, 0, 0 as a possibility, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. 8. This is a palindrome, of course, because over the whole number we have a palindrome. This will also result with this here in a palindrome of length 6. Let's write actually the length of each palindrome. Let's write the length of the smallest palindrome. I don't know. With the 3 zeros and 2 zeros here, we can get a palindrome of length 5. Here it's I think here's the smallest 6. I can't see how there's a 5 number palindrome. No, I don't think so. With this one we have a palindrome of length 5, and it is 1, 0, 0, 0, 1. With this one here, we again have this 1, 0, 0, 1 palindrome. Actually, we found already out that this has to be a 1, I think, and by symmetry this also has to be a 1, so Yeah, this one again is the symmetry of this one, so this is a palindrome of length 6. This could be a possible solution, but with this, now I'm confused. Now I think every possible... it's impossible. Sorry. Okay, so this case is actually impossible. Yeah, because this is a palindrome over the whole string, which is 9. This is a palindrome of length 5 again, with 1, 0, 0, 0, 1. And all ones again give a 9 length palindrome. In the other test case we can surely, so we are not allowed to put 0, 1 here, but everything else is possible. Yeah. For example, 1, 1 or 1, 0 would all destroy the 5 length palindrome. So I was now wondering about the 4 length palindrome, why the condition is 5 and not 4. And you can see you have to somehow argue with overlapping intervals of palindrome substrings basically. So let's say we start with some x, y, z, and we are not allowed to have 4 number palindromes. Then either y has to be unequal to z, or x has to be unequal to this letter here. I'm now thinking again about this edge case, which I thought about. So this is a simple case where we have no 4-letter palindrome, but of course we have 5-letter palindromes and 7-letter palindromes. Now, that means basically always changing the digit from 0 to 1 is not a valid solution for longer strings. That means we have 2 of the same digits somewhere. So if we have, for example, 1, 1, and it's surrounded by digits, then if we wouldn't allow 4-letter palindromes, let's say this is an x, and this has to be basically the anti-x, because if x and y are the same, we have a 4-letter palindrome. So x and y are now different, and because it doesn't matter if we read the number from left to right or right to left, we can just say without loss of generality, the 1 is here and the 0 is here. Now, if we don't allow 5-letter palindromes as well, this means this can't be a 0, so this has to be a 1, and this is fine actually. Now and now we actually have a 4-letter palindrome. Oh, I see. So I guess if you start with 4, then there are only very short numbers you can make, which without, because as soon as you have 2 in a long string, 2 numbers in the middle that are the same and consecutive, you can do the logic we just did and find a 4-letter palindrome. That means the 2 same digits have to be actually very close together, very close to the beginning or the end, and then everything after that has to be switching around. But as soon as you have 5 of these switching around, you have here a palindrome again. So yeah, the string overall can't become very large if you start at 4. Now, is it the same with 5? That's what I'm wondering. Why is 4 special in this case, or 5? But starting from 5 doesn't allow this. Can I find an infinitely long string which has no palindromes of the length 5 or longer. So let's just start. 0, 1, 0, 1. Now this can't be a 0, so let's make it 1. Now this can, I think, be anything, so let's put a 0 here again. Now this here can't be a 1, because then we would have a 6-letter palindrome. So it has to be a 0, and 0 is fine. And now here, I think both 0 and 1 are fine. So let's put a 1 again. Now here I can't put a 1, because then I have again a 6-letter palindrome, so let's put a 0. 5 is okay, 6 is okay, 7. Length palindrome is okay, 8, yeah, it's fine. Here I can't put a 0, because then I have 5 palindromes, so I put a 1. And is still fine. For larger lengths, 6 is fine, 7 is fine, 9 is fine, yes. Here I can't put a 0, so I have to put a 1 again. And 5 is fine, 6 is fine, 7 is fine, 8 is fine, and it's all fine. Here I can put, I think, anything again. So I don't see any real collision, and sometimes I have a lot of possibilities. And I can't really see a good way to approach this problem yet. I just, in the middle of going through this example, I had the feeling I could do something like dynamic programming, where I'm not sure what I should, so going from left to right, creating a table, and here I basically have the index I until which I've parsed my string, and then the two possibilities in position I to put a 0 or 1. Sometimes I just have the one position given, but if there's a question mark, I can choose between the two. And what do I want to track? Yeah, that's what I'm not clear about, actually. I thought something like the length of the smallest substring that could be a palindrome. But I'm also asking myself is if the future decision is affected. So in this example for the last digit, I had the possibility to put either a 0 or a 1, I think. Because neither one would produce palindrome. And let's say I put an X here, does this affect my ability to put anything here? Yes, it does. If this, for example, was a 0, I couldn't put a 1 here, because then I had a 6 palindrome. And if this is a 1, I couldn't put a 0 here, because then I had a 5 number palindrome. So this position affects this position. That's really annoying. What kind of time complexity can we allow? When n is the length of the string, n is equal 5 times 10 to the power of 4, then n squared is 25 times 10 to the power of 8. So n squared, I guess, would already be too slow. Because we have 100 test cases. We have actually 90 seconds. Yeah, but 20. So this is be 2.5 times 10 to the power of 9. And I always say 10 to the power of 9. Operations takes roughly 1 second, so this would be if this is the order n squared, it would be 2.5 seconds per test case, times 100 would be 250 seconds instead of 90. So yeah, this, I think n squared is too large. I mean, n times log n would be something that would be totally feasible. Or even log n, but nothing above that. Did I do anything with binary search over the string? I don't think so. All the substrings are not allowed to be palindromes. Why did I erase my example here? I think it was quite interesting. Sorry, I'm a bit stuck. I have no really good ideas right now. I felt my example was quite constructive in terms of I always knew what I had to do, and it felt like I could go on forever. Like every time I had the possibility to choose 0 or 1, it didn't seem it really mattered because, well, I know it could matter if the few further digits I don't have a choice. And then if I take the wrong one and it doesn't match with the one given, then of course everything is broken. Now again, thinking about the n squared approach, it seems like I could go over all substrings of a specific length and collect all the information I get for the question marks from this. But for the length, if I look for substrings of length s, then I have the number of substrings are n minus s. And if I sum over all possible lengths, which are 5 to including n, this is right, this must be +1, right? So if I have, for example, substring length n, then I have exactly one possible string to look at. So this is equal to n squared. It's n times n. I think it's roughly n squared half actually. Which I don't know if I can do an early break, because now with the n squared half we are at 1.25 seconds roughly, and so over 125 test case we are at 100 test case we are at 125 seconds, which is actually quite close to 90 seconds. So maybe another factor of 2 actually would just be enough to make this work. But then again, there would be the need for some constant operation for every substring looking like this, and I don't think I can get a constant here, because again then I would need to iterate over all the digits. Yes. I think it has to be a dynamic programming approach. Is it maybe that I only have to look at the last 5 question marks or so to determine how they need to be ordered? Yeah, so just had a great idea actually. I think I did a mistake up here. In these 2 cases where I said the smallest palindrome is 9, it's actually because if I take the whole 9 string, I have 1, 0, 0, 1, 0, 1, 0, 0, 1. But I can shave off the 2 1s, and then I have a palindrome of 7, and actually I can say shave off another 2 of the zeros, and I have a palindrome of only 5. So actually, in this case as well actually, and because of the shaving off, I can always reduce any palindrome of length n to a palindrome of length n minus 2. That means if I have a palindrome somewhere of length 100, it means there's a substring inside this palindrome of length 6, which is also a palindrome. In return, this means I only have to check actually that there are no palindromes of length 5 or 6 inside my string. I have to check this anyway, but it also means that as soon as I have fulfilled these 2 conditions, that there are none of those palindromes, then there can't be any larger ones as well. It means I don't have to check over all the s, but just over the s from 5 to 6. And there are quite a few, so this is now roughly each of them there are n, but this is just 2n and not n squared anymore, if I go over this. And now I actually think my dynamic programming solution starts to work, because I only have to track all the possibilities for my last 5 or 6 digits. If I know my 5 last or 6 digits I looked at, and all the possible combinations for those positions, I can decide what possibilities for the next digit are open. So if there's I have tracked all my possibilities for, I think I only need the last 5 positions. So, and there are at most 2 to the power of 5 possibilities, which is 32. So that's really not a lot. Then I can go over all these 32 combinations and check with the combination of my next digit, which is either a 1, a 0, or a question mark. In the case of a 1 or a 0, I just have to check which of these possibilities might produce a palindrome of length 5 or 6. Because I have 5 digits plus my new one, this are in total 6, so I have all the information I need in this case. And I filter my list down to only the possibilities which give me not palindrome, ending at the current position I'm looking at. And then I basically have my last 6 digits, and I cut from all these possibilities the front off, and I again have all my possibilities for the last 5 digits. And in the case I have a question mark, I basically do the same as in the case with 0, 1, but I add actually both possibilities into my list. Check again which of these fulfill the criterion of not being palindrome of 5 or 6. Filter my list and again shave off the first digit. Now thinking about the data structure on which to hold all my possibilities. So if I look at the number of possibilities with my 6th digit which I had to add, then this is of course 64. And now I'm thinking if I should have a set over strings, or if I should have an array of size 64 to update always. And here the integer basically represents the binary number which I get here. So in a set, it's quite easy to add and remove elements and check doubles, because I don't want to have doubles. This would be a bool array of size 64. If I have to shave off the first digit from a binary number basically, it is the equivalent of taking modulo 32, I would say. And this is the rest. That would be also quite an easy operation, right? Yeah. I think this is a better approach, and it should be quite easy to implement these operations of adding a digit at the end and shaving one off at the beginning. So let's start implementing this solution. We need to read in our data. We first get the number n, the length, and then the string s. Our output will be string, impossible or possible. We need a function which checks if the number contains a palindrome, 5 or 6. And we get the number n here. And we will actually use this for our init function to initialize an array which yes. So in the init function I will just go over all the possible numbers, which is up to 46. For length 6, yes. And then I can just use this for constant time. Check if something is a palindrome. Now we have to implement the check. So this checks if the last digit is a 1. No, this basically gives us just the last digit. It's a 0 or 1. And this is equal to the 5th digit and the 2nd is equal to the 4th digit. Then we have a length 5 palindrome. And for length 6, we need to modify this a bit. So, in this case, we have no palindrome, we try 1 and 4, and 2 and 3. Yes. I used I for some reason. And let's print this. Okay. Can we just say our string starts with a lot of zeros? No, I don't think we can. It's different than saying it has to start somewhere. So we need to initialize our first 4 digits. No, our first 5 digits, right? So let's set result to possible. And if at some point we find that we have no possibilities actually, then we will break the return impossible. Or we can actually say that we have only zeros in the beginning because they will just be pushed back. Yes. This is yes. How do I initialize this with 0? I always forget. Doesn't like this at all. Likes this, okay. And in the beginning we have only 0 possibility. Then we need to add the first 4 digits. Yeah. And then we need to perform the checks after we added the first 4 digits. First 5 digits. Actually, n can be 1. What? And a smaller than 5 we can just return. Because in this case, yeah. Now we iterate over all the letters. And we first push them back into our possibilities. Now we need to check. This is a 0 or this is a question mark, then we can add a 0 at the end, which is basically going through all the possibilities, multiplying them by 2. And now I see it would be better to actually have sets. But sets of integers, yes. So for each possibility, the next one is p times 2, but modulo 1 to the power of 6, which is 64, so I can just write it like this. Yes. And if this is a really possibility, it has no 5 or 6 palindromes. We should do the check later, because for the first 5 letters we don't want to do this check. Actually, let's put this here. If e smaller or equal to smaller 5, or not contains 5 or 6, then we can put this possibility into our new possibility array. And we do the same with ones, but here our operation is p times 2 to shift it to the left, so plus 1, then modulo, and check again. So for n equal to 5, I will go up to 4, so this will be always true. Here we should set pos to new pos. And we can always check if pos font size equal to 0, result equals to impossible. We lost all possibilities. We can break this for loop. And if n is equal to 5, we should check that there are some possibilities. And we now need to do this contains 5 or 6 because it never has been checked for n equal to 5. For n equal to 6, we do with the I equal to 5 iteration do it right here. Oops, we will print it. So let's just set it to impossible, and if we find one possibility that doesn't contain 5 or 6, then we can say the result is possible, and then the function is finished anyway. So I think this would be a solution. Plus minus me not implementing it well at this point because I don't exactly know what the precedences are of the operators. Oh, it seemed to work right up from the start. So all zeros. I formulated the contains wrong way around, right? And actually, I can see already that this is wrong because for 0, the number 0 means 6 zeros basically, which it's really weird that this actually then worked. Should be this, sure enough. So at some point it breaks it all down. Yeah, but I can see that this is actually very wrong. And I formulated it the wrong way around. So not contains 5, 6 is okay. Not contains 5, 6 is okay. And not contains, then we are possible. Yes. And now I formulated it here the wrong way around, because if it in this case, if this is true, it contains a 5 or 6. So this should be true. In this case, it also contains the 6. And in this case, it should be false. Now I've just inverted this. That means we've got still a wrong result. Interestingly, it still works. It's really curious. So all zeros contains 5 or 6. Then 0001 should be the 5 case, which is not working here. So first put these all into brackets. All zeros contains a 5, and this is still not working. So I need to bracket this equal condition. Still not. I'm getting a bit confused. Zero contains a 5, but 1 does not contain a 5. Oh, I have to check the shifted version of this, of course. Yeah, I did this pretty stupid. So these are the last 5 digits, or if now I need the first 5 digits, how do I get the first 5 digits? It's just dividing by 2 or shifting to divide by 1. Yes. Zero contains a 5, 4 is 00100. Yes, it's also a 5 palindrome. 10 01010, right? Yeah, a plus 2. 14 is 01110, yes. 17 is 1111. No, 17 is 10001, yes. Okay, yeah. Now I'm starting to compute this by hand just to check this stupid array. So let's check. This contains a palindrome. This contains a palindrome here on the left. This contains not a palindrome. This one also not. This one contains a 5 palindrome. This one does not. This one does not. No. No. Oh yes, it does. The first 5. Okay. Again, the first 5. Last 5. This one is not. So we have palindrome, palindrome, not, palindrome, 3 times not, 3 times yes, no, 12 should be a yes again, and then looks right, that's a 6 palindrome actually. So I think the precedence operators here worked like they should. So I'm going to test this solution now. Wish me luck. Just have a look on my private computer. What the precedence of the operators is. Oh, but it went through, so we're looking good for this one. So from all the operators I used here, which is AND, or, equal, bit shift, and a bitwise AND, we have actually that the highest precedence of those are the bitwise shift operators. So actually I could have left these brackets away. Then comes the equal signs here. Okay, so this would be a problem with the bitwise AND, which comes later. So it was important to bracket these, but I guess I have those from the beginning. Yeah. And yeah, so these come quite early, and then these ones, they come pretty late in the precedence order. Yes. I'm not sure if there's any good way to remember this. I guess I could remember that you often use equality and AND operations, that those don't need brackets. But that these bitwise ANDs come after these, I'm not sure if. No, not sure how one would remember that. But yeah, I hope the solution became a bit clear, how I did it. This is just here computing this one, my init function, which is done before all the test cases t. So just once for all 100 test cases, just to have this lookup very fast and not need to iterate over these if constructs, only just once in the beginning for all 64 combinations. And then again here I'm just adding zeros and ones, and in the case of question marks I do actually both. Construct my new possibilities by always taking my current possibilities, shifting them to the left and putting a 0 or 1 behind them, The modulo operator cuts just off the first of the digits. And when I have this new digit constructed, I check if it contains any 5 or 6 palindromes. And if it doesn't, I can keep it as one of the possibilities to go on. And it's nice actually in this problem that we didn't have to construct the actual possibilities in the case it was possible, because then we would need to do a lot of backtracking to come up with the right string. And then this is just to handle the edge case, because I've initialized basically possibilities with the all zero string. And this, of course, if, for example, the number starts with a 0 here, then we would read in first 0, get the new possibility only to be 0, and that, of course, contains palindromes, and then we wouldn't insert it. We would have empty possibilities and directly baked with impossible, just because the first digit is a 0. So we must, because we have this beginning initialization phase, we need to make sure that we don't check this in the case for the first 4 letters. First 5 letters actually. And then as soon as we took the 6th digit, we actually now have fully initialized our 6 digits in the start, and now we can do this correctly because we don't have any of the zeros from the initial possibility, because they were all kicked out after the 6th adding. And this again is in the case where we didn't have actually 6 digits in our beginning. Then, because this function was never called yet, just need to make sure the current p actually does not. Actually, now I'm wondering. Okay, that's interesting. I think my so the string of 0, only 0 with no question marks, surely does not contain any palindromes of length 5 or more. But I think the program says it's now impossible. It's possible. Ah, yes, because we catched actually the case of n smaller to 5 here. Okay, but what is with exactly 5 letters? What is with this special case? Because now I think it says impossible. Yes. But it's actually possible. And the problem says that it's impossible because it checks for it basically still has this 1 0 in the beginning. And then it says a 6 palindrome. Whereas it actually doesn't have the 0 leading 0. So I think the fix would be to just do the call with our 5 palindrome. And then we would get possible. Yes, and that would be actually correct. So I will add this test case here. Yeah, so actually we found a test case now which wasn't covered by Kickstart, lucky for us. Very special construction with the zeros. We could have actually started also with leading ones, for example, if we put not 0 in here but 63. It would be the representation with all ones. And then there would be a different test case which would have failed for us. But for only this very specific instance of just 5 digits and yeah, no question mark. which I guess is kind of boring. Yeah. Now it should be bug-free, I hope. So this was quite a long one. It took me quite a while to figure this out. Even though in the end it seemed quite easy, I just missed this. You only need to check for 5 or 6 string palindromes. Then it became, I would say, quite manageable problem. Because it comes down to n times 2 possible palindromes to look at. There are possibly many different ways how one could solve this. I did it with dynamic programming over the position of the string, which worked quite well. Code is not too complicated, I would say. So if you liked this video, if it helped you in any way, have a look at my old videos. I'm really looking forward to CodeJam qualification round this weekend now. I'll try to do problem 4 of Kickstart round 8 tomorrow evening. Let's see what it is. Interesting integers, possibly the hardest one of those 4. I found the first 2 now very easy. I've already uploaded them, have a look. This one was already a bit harder. But yeah, let's see how it goes tomorrow with the interesting integers, and then on the weekend, stay tuned for my upload of the qualification round to compare notes. How did you do? And how did I do? And then hope for an interesting CodeJam competition this year. Ring the bell, write a nice comment maybe. I always enjoy reading those, and see you. Bye.